Welcome to your next quest. Now, if you're up to this quest, you're going to implement Net Serialize for our custom effect context. Now, for this one, make a uint32 so we can accommodate for all of our variables, call it rep bits, and flip bits on it for each variable when loading. Now, make sure to call serialize bits on rep bits, and then check each bit and archive or unarchive for each variable based on whether that bit has been flipped. Now, make sure you're looking at how Net Serialize is implemented in gameplay effect types and see if you can handle this and make any adjustments that you think should be made so that we can serialize our two new Boolean variables. Now, that's okay if you're a little intimidated by this one. I understand if you want to skip it and just do it along with me. But if you'd like, and if you're up to the challenge, give it a try. So pause the video and conquer this quest now. Welcome back. Now here's Net Serialize for gameplay effect types. It uses an uint8, but we're going to use a uint32 because we plan on accommodating for more than just 8 variables. So I'm going to go into my aura ability types.cpp. And we're going to start handling things here. Now, first, I'll make my uint32 called rep bits and initialize it to 0. And then I need to check if my archive is saving. So we're going to say if ar.isSaving, then we have some bits to flip, right? Now, I'm going to go ahead and just take some code from gameplay effect types. I do want to flip bits for the instigator, for the effect causer, the source object, our actors array, our hit result, and has world origin. I'm going to go ahead and just copy all of these if statements and come back over to aura ability types, write in my if statement here, and paste them in. The only difference is I'd like to use the next 2 bits on my integer rep bits for my 2 booleans. And really, what we can check is the Boolean value of them. We can see if B is blocked hit is true or false, and B is critical hit. If they're false, no need to serialize them, right? So let's check. First, I'll check if B is blocked hit. If it is, we'll flip the bit on rep bits. Now, we're going to use bitwise or equals. And the last bit we flipped was the 6th one. So now we're going to flip the 7th. We're going to say 1, left shift 7, just like that. And we'll do this for the next Boolean, if B is critical hit. If so, we'll flip the 8th bit. So we'll say rep bits, bitwise or equals, 1, left shift 8. So that's the first step. Now let's take a look at gameplay effect types. After flipping bits, we call the archive serialize bits function. Passing in rep bits, it's actually passing in the address of rep bits. Notice serialize bits takes a void pointer. That means it can take in a pointer to anything. We're passing in the pointer to rep bits. And the length of the bits. Now, we're going to be using 2 more bits. So we need to call this with 9 here instead of 7. So we're going to copy it, come back into aura ability types, and just after the isSaving if statement, we're going to call serialize bits, passing in rep bits, the address of it, and the length in bits is going to be 2 more because we added 2 more bits that we've flipped on that integer. So length bits is 9. And that's okay if you missed that part. But that's a very subtle nuance that you need to know about for this to work properly. Now back in gameplay effect types, we have the checking of the bits for instigator, effect causer, ability CDO, source object, the actors array, the hit result, the world origin. Notice that the world origin has an else case. If that bit has been flipped, the 6th one, then it's going to archive world origin. It's also going to set B has world origin to true, but in the false case, it's not going to serialize, but it is going to set B has world origin to false, right? Interesting. Well, we're going to go ahead and take everything down to here, right? So starting all the way up here, just after serialized bits, all the way down here to the world origin. We're going to go ahead and copy that, come back over here into our function and paste it in. So that takes care of everything except for our two variables, right? So we have to check against 1 left shift 7 and 1 left shift 8, as those are the places here that we care about. So let's check. So first we're going to say if, and we're going to check rep bits, bitwise and we'll put this in parentheses. We're going to say 1 left shift 7. If that is true, then we know that we serialized. What did we serialize? One of our booleans, right? We serialized B is blocked hit. So we want to use the archive with the left shift operator, and our B is blocked hit. So we're going to say AR left shift, B is blocked hit. And then we'll do the same thing for B is critical hit, only we're checking against 1 left shift 8, and we're going to use the operator with B is critical hit, like that. Okay, so that takes care of almost everything. Let's check our gameplay effect types. We'll see that there's just a couple things left. One is if the archive is loading, we can call add instigator. We can do that as well. And we can also set B out success to true. So let's just copy those, and we'll go back into our net serialize, and we'll paste those in. And now we have successfully implemented net serialize. We're one step closer to having our own custom gameplay effect context class. We're almost ready to start learning how to use it, but there's one more important detail that we haven't quite looked at yet, and we'll look at that next. Excellent job, and if you did this challenge, I'm very proud of you. It was a little bit more intimidating with all of this cryptic looking code. We're messing with bits, so we're getting a little bit lower level, but this is a little more advanced. So I'm proud of you for sticking through it. So great job, and I'll see you soon.